Hi, welcome to the show. So after I shot and released the second episode, I had very quick discussion with my student, and then he asked a question about what about the F open access, and a couple of things we discussed. Of course, I told other than this, we can discuss when we have the session, upcoming session. Sometime it is scheduled this week, but then again I thought this is something I can of course cover as a small extension, and not just that, we can also extend some more of the code so that we can give a more of a professional touch. So this time as a change, what I have done is I got the small 8x8 LED matrix, as you can see here. Let me zoom the camera. See, you can see there, this is the small 8x8 LED matrix. So similarly I have hooked up with a resistor, and those couple of bunch of resistors I moved them away. You can see that since the breadboard is not sufficient, luckily I have this small tiny extended breadboard. I just put it over here, just like you fit pieces of Lego. Okay, so of course you can see all these breadboards will have some sort of tiny notches. Over here there is a small notch. Let me get the focus. Yes, so you can see there's a small notch, and again here there's a small notch for this breadboard. Okay, so you can see there I connected a common resistor so that I can just turn up one of the LEDs, unlike this RGB LED, because this is going to be much more brighter. Okay, yes. So what we do is it's all the same setup. I'm going to use the same pin which I used last time as well. Okay, it is going to be pin 11. You can see there I just logged it to Pi, and what we do is we can open the code just like before. So cd test Pi, and we can do history, and we can do grep 11 something like that, and grep echo, because this is where we are turning on that pin. Since it is done in sudo, we can do sudo su something like that, and then we can do that grep. So grep history grep 11 grep echo. Okay, so you can see there we are doing this, and then we are doing the direction also we are setting it over there. So something like this we can attempt. What we can do is we can just check the path before that. So cd sys, we did it in class and GPIO, and you can see there that's the file GPIO export. Okay, so something like this we can attempt. Okay, so what I can do is I can open another tab, and we can do SSH again to Pi, so that one side we can have a console, the other side we can do the code. Okay, so typically I don't like doing code with a VI editor, but since I connected time being remotely, I just want to do it this way. Okay, I'm more comfortable doing a code in a tool like this Bluefish or some sort of text editor. Okay, yep. We go here and test Pi. Yes, we are here, and this is our code. By the way, this is going to be the 4th episode of that previous 3 series, and this is going to be an extension. And again, this, if it kind of gets little extensive, then I may split this as well into couple of episodes. Okay, so cat led c.c, you can see there this is what I have done previously, and and that other file is that led php.php, and this is the PHP variant. Okay, so you can see there what we can do is we can do something like this in C as well. Okay, we just do with API. So we can take this sort of an arrangement. Okay, we go to the C stuff, vim led c.c, and we can convert that into a neat sort of API. Okay, so we do that, we copy paste that PHP stuff, and all we need to do is port it in C. Okay, so we have to get some return. So in this case, I don't want to return any int or something. There is nothing status or anything to return. We need to define this variables, because if it is C, we need to data type of these variables. So we define something like int pin number. Okay, and we can hard code this as 11. And then we can do similarly what we did it in PHP as well. Okay, so we can do hash define state on 1, and hash define state underscore off is 0, and we can neatly indent these things. Of course, I like global variables below this. I just don't like that sticking over here. So let me pull this down. Let me pull this down, insert, and then I can try, undo, insert. I can just copy this, edit, yes, and then here I can try to insert, undo, insert. Let me retype this, pin underscore number equal to 11. So we are just hard coding this pin number, and then we can change this to C type of API. So int pin number, and then int state, and then we have to construct this system statement. So we can try this variant, and then we can chain this to that fopen kind of the way you do in C by opening files and stuff. So I told him that this is a quick hack, but of course if he wishes, he can do that way as well. Okay, and same thing if you do any character driver of kernel's driver access in user space, of course you will do something like that. Okay, we can just time being we can comment this, and we can take this as a reference. Okay, we can do some unsigned char, and let's take some test buffer. Okay, test buff of say something like 500 bytes. I'm kind of generous when I define any buffers. Okay, so you can define it a much smaller number. We can do is an sprintf, and we need to construct this whatever this is actually. Okay, so that's all it is. This is just annoying. This is why I hate doing things in VI editor. Okay, let's see if I can. I'm unable to copy this. Okay, let's see if I can paste it over here. No, undo. Let me retype. It's fine. Echo state is that state. So %d, and then the redirection, and then the path. Okay, sys class GPIO. GPIO and then pin number, so %d, and then slash value. Yes, yeah, that's all. Okay, so we do this way, and what we do is we can do this. We can pass this pin number and then state as arguments. I can make it a bit I can change this variable name, because one we are calling as pin number, we can make the other one as pin state, something like that. Okay, so pin state. So this sounds much easy to understand. So it's just a personal choice. Okay, see, we have done sprintf, and we have to pass that. Let's just check what is the man page of sprintf. Okay, man sprintf, it should be the string and then followed by yes. So whatever we construct, it should go into that buffer. So we construct that, and it should be copied to that buffer. So that's the whole point of doing this sprintf. test buff, and we do that. So we constructed a string. Unfortunately, this is what we need to deal when we do things in C, because it is not so convenient like any scripting language like PHP, Python, or things like that. So we construct here, and then we do this system command. So system, now you can pass the test buff. It is like any other regular string which is terminated by \0 or null character. So just as a character buffer. Okay, so we just pass that. This should do the job. Okay, and what we do is we can replace this whole couple of lines with that API call. Okay, so let me save before that and insert. I can comment this and then comment this, and then we can replace this with that set GPIO, and then pin is pin number, because we have it as a global variable. This if you don't want to create any confusion or any namespace issue or something, like this is quite important when you do things like this in kernel space. Okay, so like I mentioned, perhaps you can pass some underscore. Okay, since I am doing it with one argument, I want to do on the other argument also. You can pass something like this. So this kind of tells us that it is something internal or something. So anyway, since it is in API, it doesn't matter. Okay, so you can do something like that, and you can just pass state on, right? So this is our hash defined macro, and set GPIO pin number state off. Okay, so that is all about it. Okay, so with this thing done, hopefully it should work. And of course I need to bring up that pin. Okay, that is also there. What I am thinking is whatever I have done here, export and this stuff, I'm thinking why not we can create an API itself. Okay, so that's much better than doing partly in command line or the command prompt and partly in the code. And we can also make this code somewhat similar to what you find the standard APIs when you do in Python or see what I discussed in the previous episode, right? So if you search any APIs, right, you can find GPIO Python code, yeah, something like that, like what I discussed in the previous episode. So we take this as a reference. You can see there we are setting that pin mode, and then we are setting up, which means it is initializing, and then you set the direction and things like that. So same thing, what we do is we can actually create such variables, create such APIs, and then we can support the state on and off as well. Okay, so let's pick this. See, this export file is in this place which is GPIO sys class GPIO. We go here, and what we do is we can just do is we create a API void. I'm doing this way. Of course you can do int, and you can capture that error, whatever the system command returns, and then you can return as well. Okay, so I'm just doing this way, hoping that it will work. Okay, which is not a good way, but it should be fine. Okay, so in this case it is we just need to pass the pin number to this file, export file, which is in this path. What we do is init GPIO something, or GPIO init GPIO pin something like that, or init pin underscore GPIO, because here it is ending with GPIO. Here also I want to end it with GPIO. We can again pass this int underscore pin underscore number, because it's just a pin number we need to save which we want. Okay, so we need that path. Okay, but once again it is sort of dynamic. You can see there we need to construct and things like that. So again the same thing, we need to do this test buff, and we do a printf, and then we populate, and then this things like that. So unsigned char test buff, say 100 bytes, because this is a very small string. Maybe you can pass, maybe if not 500 as well. So we do that, and it's the same thing. Okay, yes, printf, we do that, test buff, and here we need to pass that number. Okay, echo %d, and then redirect sys, or we can I can do a copy paste. Yeah, sys GPIO export. So that is the file name. We pass that and it will get initialized. Okay, this thing, and yep, and you can pass that pin number here, pin underscore number. We delete this, and then it should do the job. After this we call this let me save. After that we call this system command, system test buff, and hopefully it should do the job. Yeah, here the double quotes is missing. Yes, yep. So after this is done, just like we do in command prompt, again we can set the direction as well. Okay, so void set direction underscore GPIO, something like that. We can do that, and int underscore direction, and we can say, we can just almost copy paste the same code. Okay, let me, if I'm unable to do this, what I do is a cat led c.c. Let me copy this whole stuff, and we can just copy paste inside the code. Okay, vim, and go here, yes, and then paste. Yes, so you can do something like that. In this case we need to set the direction. Okay, %d, which is yeah, percentage, the direction is actually, it's a string. In that case we just send a pointer, unsigned char star, something you can pass. Okay, percentage yes, and you can say GPIO. Yeah, it is actually pin number and then direction. Okay, so we can pass int underscore pin number, and which pin and what is the direction. Okay, so if you come here, you can see it is inside this folder and direction. So it is like this. Okay, so which is GPIO, and then GPIO %d. Please note it is similar to this, but we need to send the command to that file called direction. Okay, so we do that, and we need to pass this pin number and comma underscore direction, right? So this yeah, direction should come first, which is that in contents of the file, and then GPIO pin number, so underscore pin number. Okay, so hopefully if it works, it is going to work. And if you want, you can even debug here. Okay, you can print what the test buff is, the contents of the test buff. Okay, so printf, and then you can do %yes, I'm sorry, %yes \n, and then test buff. You can do that here, you can do that here. Okay, printf %yes \n test buff, right? So you can do something like that, and you can do even here as well. Okay, so printf, so it tells us before it being executed, what is that we are trying to pass to the system. Okay, so you can do something like this. So we have our debug in place. Okay, so I'm generally, I don't do this in a production code, but